All right, let's take a journey, not just to another place, but to another time. We're going way, way back, 460 million years, to be precise, to a version of our own planet that you wouldn't even recognize. Seriously, picture an Earth where the day whips by in just 21 hours, where the moon hangs in the sky, huge and imposing, closer than it's ever been to us. The sun itself is a little dimmer, a little younger, casting a different kind of light on a world where the continents are in all the wrong places, and in the oceans, life is just going wild. It's an explosion of creativity. But what if I told you that this already alien world had another feature? Something so strange, so out of place, that we've only ever seen it on the giant gas planets out in the cold depths of our solar system. New evidence, a compelling new theory, suggests that for a time, our ancient Earth had a magnificent dusty ring. Today, we're going to be detectives. We're going to follow a single, bizarre clue that unravels this whole mystery and in the process completely rewrites our understanding of this lost world, the strange creatures that called it home, and the cataclysm that brought it all to an end.
So where do we even begin a story this wild? Well, it doesn't start with some grand, sweeping theory. It doesn't start with a spectacular fossil discovery. Nope. Like so many of the greatest scientific detective stories, this one begins with a loose thread, an anomaly, a little piece of data that just doesn't fit. It's the kind of thing that makes a scientist sit up and go, huh, that's weird. It's a geological mystery that for years had researchers scratching their heads, completely baffled, because the evidence in the rocks was telling them a story that, by all accounts, should have been impossible. And here it is. This is the mystery. We're looking at a specific slice of time called the Mid-Ordovician period, right around 466 million years ago. And during this window, something incredibly strange was happening with meteorite impacts. Now, you have to understand, impacts from space are supposed to be the definition of random. An asteroid or a comet doesn't aim. It doesn't care about geography. It doesn't care about latitude or longitude. It's on a collision course, and it hits wherever its path intersects with Earth. Think of it like a rainstorm. The drops fall everywhere, but back in the Ordovician, it wasn't raining everywhere. It was as if every single meteorite, for millions of years, was being guided by an invisible hand, hitting the planet with a weird and almost impossible precision.
Impossible is a strong word. But what does it mean in numbers? While scientists did the math, they calculated the odds of this particular pattern of meteorite strikes happening purely by chance. The result? 1 in 25 million. Let that sink in. 1 in 25 million. Your odds of winning the Powerball are better than that. This isn't the kind of number you just shrug off as a statistical fluke or a coincidence. No way. This is what scientists call a statistical smoking gun. It's a number so outrageously improbable that it screams at you, telling you that your fundamental understanding of the system is wrong. The universe was trying to tell geologists that they were missing a huge, critical piece of the puzzle about how our planet worked back then.
Okay, so let's break down the evidence, because this is what makes that number so concrete. Researchers did this incredible, painstaking work of reconstructing what Earth looked like 466 million years ago. They moved the continents back to their ancient positions. Then they identified 21 major confirmed impact craters from that specific time. And what did they find? Every single one of them was clustered in a narrow band within 30 degrees of the ancient equator. But here's the real kicker. The best places on a planet to preserve a crater for hundreds of millions of years are these old, geologically stable chunks of continent called cratons. They're like solid rocky vaults. And back in the Ordovician, 70% of this prime crater-preserving real estate was located at high latitudes, way up north and way down south. And how many craters did they find there? Zero. None. Not a single one. Just imagine a giant dartboard. Now imagine 70% of that board is made of perfect soft cork, while a narrow little strip in the middle is made of solid steel. And somehow, for millions of years, every single dart you throw not only misses the giant cork target, but hits that tiny steel band. It makes absolutely no sense, unless, of course, the darts weren't coming from the front, unless they were coming from somewhere else entirely.
So, what on Earth, or off of it, could possibly explain this 1 in 25 million shot? What kind of bizarre cosmic shooting gallery could target our planet's equator with such unerring precision and keep it up for millions of years? The answer, proposed in a groundbreaking hypothesis published just in 2024, is as dramatic as it is elegant. It suggests that for a brief, shining moment in its long history, our blue marble of a planet looked a whole lot more like Saturn.
The idea is officially called the Earth Ring Hypothesis, and it's a beauty. It proposes that a big asteroid, maybe the parent body of a specific type of meteorite we see a lot of from this period, wandered just a little too close to our planet. It didn't smash right into us. Instead, it was caught, like a fly in a spider web, by Earth's powerful gravity. And as its orbit got closer and closer, our planet's gravity didn't just hold it It systematically destroyed it, ripping it to shreds. All that dust and debris and rubble then spread out, forming a temporary but probably magnificent ring system right over the equator. And suddenly, the whole mystery clicks into place. The meteorite bullets weren't random projectiles coming from the depths of space. They were our own local debris, pieces of our very own ring, slowly losing energy and raining down on the part of the planet right below them.
This whole process is governed by a really cool concept in celestial mechanics called the Roche limit. Think of it as an invisible line of death around any big planet. If a smaller object, like an asteroid that's only held together by its own weak gravity, crosses that line, it's game over. The planet's gravitational pull on the near side of the asteroid becomes so much stronger than the pull on its far side that it literally stretches and tears the object apart. All that resulting rubble is now trapped in orbit. And because of the planet's rotation, all that debris gets flattened out into a perfect flat disk right above the equator. Then, over the next few million years, things like atmospheric drag and even the gentle pressure of sunlight would cause this ring material to slowly, gradually spiral inwards. It would rain down on Earth, peppering the equatorial regions with a constant shower of impacts. And what's so powerful about this theory is that it doesn't just explain the weird location of the craters, it also solves another long-standing puzzle. A huge, unexplained spike of a specific meteorite type, called L-chondrites, and a massive amount of cosmic dust found in Ordovician sediments all over the world. The ring was the local source, constantly shedding this exact material for a very, very long time. It all fits.
But wait, there's more. The ring didn't just solve the meteorite mystery. The fact that it might have existed solves an even bigger, more profound paradox from this era, a climate puzzle that has stumped scientists for decades. You see, on the one hand, all our geochemical data, the chemistry of the rocks, tells us that the Ordovician atmosphere was a super greenhouse. CO2 levels were somewhere between 8 and 20 times higher than they were before the Industrial Revolution. We're talking levels that today would mean catastrophic global warming. A thick heat-trapping blanket was wrapped around the planet. And yet, the geological evidence is equally clear. The period ended with the planet plunging into one of the most severe ice ages of the last half-billion years. So how? How can a planet with that much heat-trapping gas in its atmosphere possibly freeze over? It's a massive contradiction. It just shouldn't be possible.
And the ring provides the most elegant solution yet. Think about it. A dense, dusty ring orbiting right over the tropics would act like a giant planetary sunshade. It would physically block and scatter a significant amount of incoming sunlight before it could ever reach the surface and get trapped by that thick CO2 blanket. It's like holding a parasol on a blistering hot day. The air is still hot, but you feel cooler in the shade. If that ring was dense enough, this shading effect could have become so powerful that it actually overrode the intense greenhouse effect. It could have tipped the global climate balance from hot to cold, plunging the planet into a deep freeze. It's an incredible idea. The very thing that would have decorated our skies with a beautiful shimmering arc may have also been the architect of our planet's greatest cold snap.
Okay, so let's accept this radical new picture for a moment. An Earth with a ring, a sky streaked with a constant meteor shower, and a global climate teetering on the edge of a catastrophic ice age, all because of that ring's shadow. What was it actually like to be on this world? What was life like beneath that shadow? Well, the conditions were truly, deeply alien. A world so profoundly different from our own, it might as well have been another planet.
Let's really try to paint this picture. First off, the whole rhythm of the planet was different. Earth was spinning faster, which means the day was only 21 hours long. A year would have been packed with over 410 of these shorter days. Now look up. The moon is much, much closer to Earth than it is today. That means it would have looked huge in the sky, a giant looming presence. And more importantly, its gravitational pull would have been way stronger, generating massive, ferocious tides that would have swept across the coasts, far more extreme than anything we see today. The light is different too. The sun, being younger, was about 4% dimmer, casting a slightly less intense glow on everything. So you had this strange, fast-paced world with giant tides and dimmer light. And in the middle of all this bizarre physics, life in the oceans wasn't just hanging on, it was exploding. It was in the middle of one of the most significant and creative evolutionary bursts in the entire history of our planet.
This event is so important, paleontologists have given it a name, the Great Ordovician Biodiversification Event, or the GOBE. Now, you've probably heard of the Cambrian explosion that came before it. If the Cambrian explosion was about inventing the basic body plans for animal life, the blueprints for a fish, or a snail, or an arthropod, then the GOBE was about taking those blueprints and building an absolutely astonishing variety of different models. It's like the Cambrian invented the concept of a car, and the GOBE invented sports cars and pickup trucks and minivans and luxury sedans. The sheer numbers are incredible. The number of marine animal families tripled, and the number of genera quadrupled. This is when the really complex marine ecosystems we recognize today, with reefs and filter feeders and specialized predators and prey, were truly established. It was a biological big bang that filled the ancient seas with a host of new and often very, very strange creatures.
And speaking of strange creatures, let's meet one of the stars of the Ordovician. This little guy, Sacabambaspis. Thanks to a wonderfully made and slightly goofy-looking museum model in Helsinki, this small, armored, jawless fish became an unlikely internet superstar in 2023. You've probably seen its face. That vacant expression, with the wide-set eyes and the downturned mouth, became a viral meme for expressing a kind of existential dread or exhaustion. But there is some incredible science behind that famous face. Sacabambaspis didn't have a jaw. It belongs to a group of our earliest vertebrate ancestors that hadn't evolved him yet. So that mouth isn't stuck open in a permanent state of shock. It was actually a highly specialized feeding hole, lined with about 60 rows of tiny bony plates. The best guess is that it used these plates to generate suction, essentially acting like a little vacuum cleaner, slurping up organic bits and tiny organisms from the mud on the seafloor. That famous, memeable face was actually a sophisticated, highly efficient dinner solution for one of our earliest relatives.
So while small vertebrates like Sacabambaspis were figuring out how to grub around on the bottom, a completely different evolutionary story was playing out among the invertebrates. This creature, a Gerocassis, had some truly terrifying ancestors. Its relatives, like the famous Anomalocaris from the Cambrian period, were the absolute terrors of their seas, the T-Rexes of their day, with fearsome, grasping claws. But a Gerocassis, which could grow to an incredible 2 meters long, took a totally different path. It went from predator to pacifist. Its front appendages evolved from weapons into these intricate, beautiful, comb-like nets. It became a filter feeder, using its massive limbs to sift tiny plankton from the water. This is a perfect illustration of the goob in action. Because life was booming, there was a huge explosion in plankton, which created a brand new ecological niche, and a Gerocassis evolved to fill it, becoming one of Earth's first ever gentle giants, playing the exact same role in its ecosystem that giant baleen whales and whale sharks do in ours today.
But of course, not all the giants were gentle. Every ecosystem needs its apex predator, and at the absolute top of the Ordovician food chain was this thing, Endoceras. This was a true sea monster. It was a type of cephalopod, so it's related to modern squid and octopuses, but instead of being soft-bodied, it had this massive, straight, cone-shaped shell. For a while, there was some confusion in the fossil record with a related animal, Phanerozoic, which some people thought was 10 meters long, but modern analysis has cleared things up, and it points to Endoceras as the true Ordovician titan. We're talking a shell up to 3 meters long, with a total body length, tentacles and all, of up to 6 meters. That's nearly 20 feet. But here's the interesting thing. Biomechanical studies show that because of the immense drag from that huge, clunky shell, an adult Endoceras probably wasn't a fast, agile swimmer chasing things down. It was more likely a slow-moving ambush predator, maybe lurking vertically in the water column or crawling along the seabed, just waiting for a big trilobite or a sea scorpion to get a little too close to its powerful tentacles.
So, we have this incredible picture, right? A vibrant, utterly alien world. A ringed planet, teeming with an explosion of new and bizarre life, from meme-faced fish to gentle giants and lurking sea monsters. But this amazing era, this world thriving under the shadow of a planetary ring and fueled by a biological boom, was destined for a sudden and truly catastrophic end. In a twist of cosmic irony, the very same factors that made this world so unique would ultimately become the architects of its destruction.
The number is just devastating. At the end of the Ordovician period, approximately 85% of all marine species were wiped from the face of the Earth. Gone. Forever. This was the Ordovician Silurian extinction event, and in terms of sheer biodiversity loss, it was the second largest of the Big Five mass extinctions in our planet's history. Just think about that. After tens of millions of years of this unprecedented evolutionary creativity, this explosion of life we call the GOB, it was like someone just walked over and flipped a switch. The lights went out all across the world's oceans.
And it wasn't a single, clean hit. It was a cruel, devastating 1-2 punch that unfolded over about 1 million years. The first pulse was the Big Freeze. That sunshade effect from the ring, probably helped along by another huge development, the first primitive plants starting to colonize land and drawing down CO2, finally tipped the climate over the edge. A full-blown ice age began. As massive ice sheets grew over the southern supercontinent of Gondwana, so much water got locked up as ice that sea levels fell by over 100 meters. The vast, shallow seas where most of life lived were simply drained away. Habitats vanished. Then came the second pulse, the toxic thaw. The Ice Age ended, and it ended fast. As the glaciers melted and the seas surged back up, it threw ocean circulation into complete chaos. This created huge dead zones with no oxygen, a condition called anoxia. So the few creatures that managed to survive the freezing cold and the loss of their homes were now suffocated in warm, stagnant, and likely toxic waters. It was one of the deadliest climate whipsaws in history.
But the story of the Ordovician doesn't just end there, with a silent, empty ocean. That's not how our planet works. The echo of this ancient alien world is still with us today, in ways that are actually kind of shocking. In fact, the biological boom from that long-lost era is literally, right now, powering a modern nation. Up in the northern European nation of Estonia, there's a unique geological deposit they call Cookersite. It's a type of very high-quality oil shale. Locals call it burning stone because you can literally just pick up a piece of this rock and set it on fire. And its origin story goes right back to the Gobi, 460 million years ago. Cookersite is made almost entirely from the fossilized remains of one specific type of colonial alga. Back in the Ordovician, this algae had massive blooms in the shallow seas that covered that region. It grew in such vast quantities that when it died and sank to the seafloor, it formed these thick, dense layers of organic ooze. Over hundreds of millions of years, that ooze was compressed into rock. And today, Estonia mines this 460 million-year-old fossilized algal sludge and uses it as its #1 energy source. They burn it to generate electricity and to produce oil. Think about that. An entire country's energy grid is running on the ghost of an Ordovician algal bloom.
And this really shows you the deep, unbreakable connection we have to this lost world. The Ordovician truly was an alien planet, governed by physics and a celestial arrangement we no longer experience. But it's not disconnected from us. The ring itself probably vanished from the sky within a few million years, but its memory is still there, etched into the planet's crust as that strange, impossible cluster of craters around the equator. The trials and evolutionary innovations of its life forms, like the body armor and the feeding strategies of our little friend Sacabambaspis, were the earliest drafts of the vertebrate blueprint that eventually, after a very long and winding road, led to us. The algal blooms that choked its ancient seas now power modern homes. The Ordovician set the stage, in boom and in bust, for so much of what was to come.
Ultimately, the Earth ring hypothesis is just a powerful, beautiful reminder of how science really works. It shows how one seemingly impossible, ridiculously improbable piece of data, that cluster of craters that simply shouldn't exist, can force us to completely rewrite our entire understanding of a geological era. It transforms our view of the Ordovician from just some transitional period between other, more famous ones into a dynamic, bizarre, and frankly awesome world worthy of science fiction. And it leaves us with this tantalizing question: what other lost worlds, what other profound secrets about our own planet's history are still out there hiding in plain sight in the rock record, just waiting for the right person to notice one strange little clue and begin to unravel it all?
Today, we're going to journey to an alien planet. Except that planet is our own Earth, just 460 million years ago. It was a world you wouldn't even recognize. A day was only 21 hours long. The moon hung huge in the sky. And maybe, just maybe, it had a glorious ring system just like Saturn's. I've got 10 questions for you to see how well you know this lost world. You think you're ready? Let's find out.
Okay, question 1, and it's a big one right out of the gate. This idea that Earth had rings is brand new. We're talking proposed in 2024, and it is totally shaking up our understanding of this ancient time. So, what's the smoking gun? What's that one piece of evidence that's got scientists seriously considering this wild idea? Go on, have a think about it.
And the answer is a really, really weird pattern of meteor strikes. It's almost impossible to explain otherwise. You see, every single one of the 21 known craters from this period is crammed into a narrow band right around the Earth's ancient equator. Now, what makes that so wild is that 70% of the best land for preserving craters was up near the poles, but there are 0 craters there. None. If meteors were just hitting randomly, that makes no sense. But if you had debris raining down from a crumbling ring system that was orbiting the equator, well, that fits the data perfectly.
So just how unlikely is this pattern we're seeing? Well, the odds of these craters landing this way just by random chance are about 1 in 25 million. Yeah, when you see a number like that in science, you know you are not looking at a coincidence. You're looking at a cause. Okay, so if Earth had a ring, it would have been more than just a spectacular sight in the sky. It would have been a massive force of nature. So, for question 2, what was its single biggest impact on the planet's climate?
The answer actually solves a huge, long-standing mystery. You see, the Ordovician was a super greenhouse world. We're talking CO2 levels maybe 20 times higher than they are today. It should have been boiling hot. And yet, the period ended in a catastrophic global ice age. How? How does that even happen? Well, a planetary ring is the first really good answer. It would have acted like a giant planetary sunshade, casting a shadow that blocked sunlight from hitting the tropics, creating a powerful global cooling effect, powerful enough to override that extreme greenhouse effect and plunge the entire world into ice.
Let's shift gears a bit to the basic physics of this alien Earth. Our 24-hour day feels like a constant, but in geologic time, it's anything but. So, question 3. How long was a single day back in the Ordovician? The Earth was spinning way faster back then. A day was only about 21 hours long. And if the days are shorter, you can fit more of them into a single trip around the sun, which means a year was somewhere around 414 to 420 days long. And the reason for all this speed? The Moon. It was much, much closer to Earth, and its gravity acts like a brake on our planet's spin. Over hundreds of millions of years, it's been slowly pulling on the reins. But back then, that brake was a lot weaker. All right, time for an internet celebrity. You've almost certainly seen the meme of this little fish, Sacabambaspis, with its hilarious vacant stare. But that permanently open mouth is pretty misleading. So, question 4 is, how did this thing actually eat? Sacabambaspis was basically a biological vacuum cleaner. The key thing to know is that it was a jawless fish. That opening wasn't a mouth like we think of it. It was lined with about 60 rows of tiny, movable bone plates. The going theory is that it would just cruise along the bottom, sucking up mouthfuls of mud and sediment, and then those internal plates would act like a sieve, filtering out all the tasty organic bits. So that famous face, which comes from the model at the Helsinki Museum, was really a super efficient mud sifting machine. For the longest time, if you picked up a book about dinosaurs, you'd see this giant 10-meter-long monster called Camerata ruling the Ordovician seas. But, science moves on. So, question 5. What creature do we now think was the real top predator? And what was its totally bizarre way of hunting? Say hello to Endoceras. Now, this thing was still a certified giant, reaching up to 6 meters or about 20 feet. But here's the twist. That massive cone-shaped shell would have created an enormous amount of drag in the water. It couldn't have been a fast, active hunter. Instead, we now think it was a patient ambush predator. It might have crawled along the seafloor or, and this is my favorite mental image, it might have just floated vertically in the water column, a silent, living depth charge, just waiting for something to swim by.
Let's stick with these giant invertebrates for a minute. If you're a fan of the Cambrian explosion, you definitely know Anomalocaris, the original nightmare predator of the ancient seas. Well, in the Ordovician, its 2-meter-long cousin Agirocassis showed up. But it had taken a hard turn down a completely different evolutionary road. What was it?
In what has to be one of the most amazing evolutionary pivots ever, Agirocassis became one of our planet's very first gentle giants. It completely gave up the predatory lifestyle. Its terrifying grasping arms evolved into this delicate feathery mesh, which it used to strain tiny plankton out of the water. It was filling the exact same ecological role that modern baleen whales do, and this was only possible because of a massive boom in plankton that was happening at the time. And that plankton boom was just one small part of a much, much bigger story. The Cambrian explosion gets all the fame for creating the basic body plans of life, but it was really the Ordovician period when life got creative and filled in all the details. So, for question 7, what do scientists call this incredible surge in biodiversity? It's known as the Great Ordovician Biodiversification Event, or you'll often hear it called GOBE for short. And that analogy is really the best way to think about it. If the Cambrian explosion drew up the architectural blueprints for life, the GOBE is when evolution started mass-producing all the different models to fill the building. The number of marine families tripled, genera quadrupled. It was an absolute explosion of complexity that built the foundation for the oceans we know today. So far, we've spent all our time in the ocean. But the Ordovician is also a huge deal because it's when life took its first shaky steps onto dry land. So, for question 8, what do we call the tiny microscopic fossil evidence that proves the very first plants had finally arrived? The answer is cryptospores. They're these microscopic fossilized spores from very primitive plants, probably something like modern liverworts.
But here's the incredible irony of the story. This first beautiful greening of the continents had a devastating side effect. As these new plants spread, they dramatically sped up the chemical weathering of rocks, and that's a process that pulls enormous amounts of carbon dioxide right out of the atmosphere. So they actually helped amplify the global cooling that the planetary ring started, pushing the world towards a mass extinction.
And that brings us to the tragic end of this amazing period. The Ordovician didn't just fade away, it ended in one of the top 5 worst mass extinctions of all time. And it came as a brutal 1-2 punch. So, for question 9, can you describe what happened during each of these 2 deadly pulses?
The first punch was the cold. As the Ice Age kicked in, so much water got locked up in massive glaciers that sea levels absolutely plummeted. All those shallow seas, which were where most of life was thriving, they just vanished. And then came the second pulse, a sudden, rapid warming. The glaciers melted, sea levels shot back up, and that massive influx of fresh water completely messed up ocean circulation. This led to huge oxygen-starved dead zones and caused toxic, metal-rich waters from the deep ocean to surge up to the surface. It was just an absolutely brutal end.
Okay, here we are at the final question. And this one is amazing because it connects this incredibly deep past directly to our world today. Some of the life from the Ordovician didn't just turn into fossils. It became a geological resource. A gigantic bloom of one particular type of algae created what's known as a burning stone that literally powers a country right now. What is it?
The answer is a type of high-quality oil shale called kukkursite. You find it in Estonia. And what's incredible is that the rock is made almost entirely from the fossilized bodies of a single species of algae that bloomed like crazy in the Ordovician seas. And today, Estonia mines this 460-million-year-old rock on an industrial scale. It is their primary national energy source. So the Ordovician isn't just ancient history. It's literally keeping the lights on in a modern country.
So how did you do on the challenge? Did you ace it? Whether you got 1 right or all 10, I hope this little trip back in time showed you what a truly bizarre and dynamic world the Ordovician was. That ring may be long gone, but the story of the life that rose and fell beneath its shadow is carved into the very rocks beneath our feet and even into our own DNA. It's a reminder that our planet's story is always being updated. Thanks so much for joining me.